Hello everyone. In this video, we will discuss about setting up Kubernetes on an AWS EC2 instance. Today, we will cover creating an EC2 instance, installing Docker and Kubernetes tools, and also managing Kubernetes resources like pods, deployments, and services. Let's get started. First, let's understand what is Kubernetes. Kubernetes is an open source platform that helps manage and organize containers. It automates the process of deploying, scaling, and managing these containers across multiple machines, making it easier to run and maintain large applications. Why Kubernetes? Okay, imagine you have a web app running in containers. Kubernetes helps you keep it running by replacing containers if they crash. Scale it by adding more containers when the traffic increases. Manage communication between the containers in a way that's simple and efficient. Okay, let's see the key benefits of Kubernetes. Portability. Kubernetes abstracts infrastructure, allowing applications to run on any platform. Scalability. Kubernetes can automatically scale applications up or down depending on demand. Self-healing. Kubernetes can automatically replace failed containers and restart them. High availability distributes workloads across multiple nodes to ensure high availability. Load balancing automatically balances traffic across pods for efficient resource use. Resource optimization. Efficient use of infrastructure resources, reducing cost. Kubernetes resources are objects like pods, deployments, and services that define and manage the deployment, scaling, and operation of applications in a Kubernetes cluster. First, what is pod? A pod is the smallest and simplest unit in Kubernetes. It represents a single instance of a running process in the cluster and can hold one or more containers. Next, what is deployment? A deployment is a higher level abstraction that manages a set of pods. It provides declarative updates for pods. Deployments ensure that the specified number of pods are always running and are automatically replaced if they fail. What is service? A service is an abstraction that defines a logical set of pods and provides a stable endpoint for accessing them. Services ensure that pods can be discovered and accessed consistently even when the pods themselves are recreated or replaced. Now, let's dive into the hands-on. First, log into your AWS console and navigate to EC2 dashboard. Click on Launch Instance. Give your instance the name Kubernetes. Select Ubuntu as the operating system and choose T3 medium for the instance type. Use an existing key pair or create a new one. Select existing security group. I'm going to select the default and that's it. Click on launch instance. Now let's install Docker. Go to Docker website and in Ubuntu section, scroll down. You can see here install using the apt repository. Copy the comments and paste it over here. Copy, install the Docker package. Then verify that installation is successful by running the hello world image. To run this command, paste it here. Yes, it's running. Next, install Kubernetes. Run the command sudo snap install kubectl classic. This command installs the kubectl tool for managing Kubernetes on your system using Snap with full system permission. So then go to Minikube, scroll down, select your operating system, Linux, copy this command and paste it over here. Then run the command minikube start. Okay, copy this command. Now run minikube start. Next, run the command kubectl get pods -e. This command lists all the running pods across all namespaces in a Kubernetes cluster. You can see here the running pods. Now clear the screen. Now search for Kubernetes pods and open this website. Scroll down, copy this script and create one file called pod.yml. Paste it over here. Let's understand this script. API version v1. It specifies the API version being used for the resource. V1 is the stable version for basic resources like pods. Kind pod. It specifies that resources being defined is a pod. Metadata. It contains about the pod, like name, Nginx. The name of the pod is set to Nginx. This is how the pod will be identified in Kubernetes. Then spec. It defines the described state of pod. Containers specifies the list of containers within the pod. In this case, there is one container. The container name is Nginx. This sets the container to use the Nginx image with version 1.14.2 from the Docker registry. Ports defines which ports the container will expose. Here, the container exposes port number 80, which is the standard port for HTTP traffic. Now, save and exit. Now run the command kubectl apply -f file name. This command tells Kubernetes to create or update resources defined in the pod YML file. If you want to check running pods, run the command kubectl get pod -o while. This command displays a list of pods in the current namespace, along with additional details like the node each pod is running on, its IP address, and other extended information. To delete the pod, run the command kubectl delete pod and copy the pod name, paste it over here. That's it. It deletes the specified pod from the Kubernetes cluster. Now create deployment.yml. Here is the script. Now let's understand line by line. API version apps v1. It specifies the API version to use for the deployment resources. Apps v1 is commonly used for deployments. Kind deployment. It indicates that this is a deployment resource used to manage application replicas and updates. Metadata provides metadata about the deployment, names the deployment as Nginx deployment, adds key value labels like app Nginx for categorization and selection. Spec defines the desired state of deployment. Replica 3. It specifies that three replicas of the Nginx pod should run. Selector identifies the pods to manage by matching the app Nginx label. Then template. It describes the pod template used to create the Nginx pods. Metadata labels app Nginx. Labels the pod with app Nginx for identification. Spec specifies the pod configuration. Containers lists the containers inside the pod and names the container as Nginx. And image version is 1.14.2 and exposes port number 80 from the container to accept HTTP traffic. Now save and exit. Now run the command kubectl apply -f file name. Now let's check the running pods. See, now three pods are running. Copy any one of the name of pod. One pod is deleted. Now let's check. See, if a pod is deleted, a new one will be automatically created to replace it. Now let's create a service. As I said, API version v1 specifies the API version to use for the resource. v1 is the stable version for service. Kind service defines the resources as a service. Metadata provides information about service. The name of the service is Nginx service. Spec defines the configuration of service. Selector tells the service to target pods with the label app Nginx, meaning it will route traffic to those pods. Port specifies which ports the service will use. Protocol TCP. The communication will use the TCP protocol. The service will listen on port number 80. The traffic will be forwarded to port number 80 of the selected ports. Now exit, run the command kubectl apply -f service.yml. Now the pods are running. Now run the command kubectl get svc. This command lists all the services in the current Kubernetes namespaces. You can see here. Now run the command minikube ssh. Minikube ssh opens an SSH connection to the Minikube virtual machine, allowing you to interact with directly. Now run the command curl -l and copy the above IP address, paste it here with the port number 8. It sends an HTTP request to the IP address 10.96.0.1 on port number 80 to retrieve the content following any redirects. kubectl now billeted. Now let's create one file for node service. Okay, API version v1 kind, it specifies the source type as a service, and then metadata. The name of the service is Nginx deployment. The type, this sets the service type to node port, which exposes the service on a static port on each node in the cluster. This makes it accessible externally via the node's IP and the specified port. This selector, the service will select ports with the label app nginx and route traffic to them, and then specify the communication protocol to be used, which is TCP, port number 80, the port the service will listen only internally within the cluster, and target port 80, the port on the selected ports that the service will forward traffic to, node port 31000, the external port on each node's IP that will be used to access that service. Now save and exit. kubectl apply kubectl svc. Now run the command minikube IP. This command returns the IP address of the minikube virtual machine, which can be used to access services running on minikube from your local machine. Now run the command curl kernel http Copy this IP address, paste it here with the port number 31,000. It sends an HTTP request to the IP address obtained from Minikube IP using the port number 31,000. See, this is the output. And that's it. Thank you.